Huawei has spent 3 years telling the entire world one story: that China doesn't need America anymore. No Nvidia, no TSMC, fully self-reliant, homegrown chips built entirely on Chinese soil, powering a homegrown AI empire that answers to nobody. It's the story that turned Huawei into a national symbol, the company that supposedly proved sanctions don't work. Here's what almost nobody is talking about. The company Huawei depends on to build those chips is failing to make them correctly 6 times out of 10. And when independent investigators physically tore open some of Huawei's own made-in-China chips to see what was really inside, they didn't find a yield problem. They found something Huawei never wanted the public to see at all. Stay with me, because by the end of this video, you're going to understand the one relationship inside China's tech industry that could quietly decide who actually wins the chip war, and it isn't the one everyone's watching. Before we go further, if you've never seen how deep this actually goes, hit subscribe right now, because the next part of this story is the exact detail almost every other channel completely missed. Here's the headline version. Huawei designs some of the most talked about AI chips on Earth, the Ascend series, built specifically to compete with Nvidia inside the Chinese market, after US export controls locked Nvidia's most powerful chips out. Huawei's Ascend 9110C has become the flagship of an entire national narrative. Proof, supposedly, that China can out-engineer sanctions. But here's the detail that rarely makes it into the headlines. Huawei doesn't actually manufacture those chips. It can't. Huawei is a designer. It draws the blueprint, the architecture, the logic. The company that actually turns that blueprint into working silicon is called SMIC, Semiconductor Manufacturing International Corporation, China's largest and most strategically important chip foundry. On paper, this partnership is the backbone of China's entire chip independence story. In reality, industry reporting now shows SMIC's yield rate, the percentage of manufactured chips that actually come off the line working correctly, for Huawei's flagship Ascend 9110C, sitting somewhere between just 20 and 40%. For context, a mature, commercially healthy chip manufacturing process typically needs yields well above 90% before it's considered viable at scale. Huawei's most important chip, the one supposed to prove China doesn't need the West anymore, is currently failing more often than it succeeds. To understand why this matters, you need to understand something most coverage of the US-China chip war gets backwards. Everyone frames this as Huawei versus Nvidia, or China versus America. But the fight that actually determines whether China's chip strategy succeeds or stalls out is happening inside China, quietly, between Huawei and its own supply chain. Here's how the relationship actually works, step by step. Huawei's engineers designed the architecture for a chip like the Ascend 9110C. Every logic gate, every circuit pathway, every calculation the chip will eventually perform. That design exists purely as digital blueprints at this stage, files on a computer. Turning that blueprint into an actual working piece of silicon requires a process called fabrication. And fabrication is brutally unforgiving. It means carving patterns onto a silicon wafer that are thousands of times thinner than a human hair, using lithography machines precise enough to essentially paint with light at a scale most people can't visualize. SMIC owns that equipment. SMIC runs those factories. Without SMIC executing that process correctly, at scale, with consistent quality, Huawei's brilliant chip designs remain exactly that: designs, not products. Here's where the story gets genuinely difficult for SMIC. The single most efficient way to perform this kind of fabrication today is with something called extreme ultraviolet lithography, EUV for short, machines so advanced that only one company on Earth, Dutch manufacturer ASML, builds them. and US-aligned export controls have specifically blocked SMIC from ever buying one. Without EUV, SMIC has had to fall back on an older technology called deep ultraviolet lithography, DUV, and force it to do a job it wasn't originally designed for. That means running each wafer through the machine multiple times, layering pattern on top of pattern in a technique called multi-patterning, essentially trying to approximate in 4 or 5 exhausting passes what an EUV machine does cleanly in one. That workaround technically works. SMIC has proven that much. But it's slower, dramatically more expensive per chip, and far less forgiving of tiny errors, because every additional pass through the machine is another opportunity for microscopic misalignment, contamination, or defects to creep in. That's exactly why Huawei's most advanced AI chip is currently coming out of Chinese factories correctly less than half the time. Picture what that actually looks like on a real factory floor in Shanghai. Out of every 10 silicon wafers, SMIC runs through this grueling multi-pass DUV process for Huawei. Roughly 6 emerge flawed, misaligned circuits, defective transistors, chips that simply won't power on correctly, or ones that work but fall short of the performance Huawei promised customers. Only about 4 in 10 survive as a usable Ascend chip. Huawei can design the single most brilliant chip architecture in the world. On paper, it can even rival elements of Nvidia's own roadmap. And none of that matters if the factory building it can't reliably turn blueprints into working silicon. But here's the part that turns this from a manufacturing headache into something much bigger, much more explosive. Because when investigators actually cracked open some of these supposedly Chinese-made Ascend chips to verify what was physically inside them, what they found wasn't a yield problem at all. It was a secret Huawei had been sitting on for years. This is the detail almost no mainstream coverage connected properly, and it's the real twist buried inside this entire story. Independent Teardown investigations conducted by Tech Insights, a firm whose entire business is physically disassembling chips, layer by layer, to verify exactly what's inside them, examined units of Huawei's Ascend 9.10B and 9.10C processors pulled from real, shipped products. Their finding was explosive. Essentially, every sample they tested contained silicon dies that were not manufactured by SMIC at all. They were manufactured by TSMC. The Taiwanese chip-making giant Huawei has been formally, legally sanctioned from ever working with again since 2020. Here's how that actually happened, and it reads like something out of a corporate thriller. Investigators determined Huawei acquired approximately 2.9 million TSMC manufactured chip dies through a company called SoftGo, a chip design firm registered in the Cayman Islands, structured in a way that obscured its ultimate connection back to Huawei's own supply chain. U.S. authorities concluded this was a deliberate sanctions evasion scheme, not an accident or a loophole. TSMC itself was fined $1 billion for its role in the violation. Think about the scale of that for a second. For years, while Huawei publicly celebrated Chinese-made AI chips as living proof of total technological self-reliance, a meaningful share of the actual silicon inside those chips had secretly come from the exact Taiwanese company America had specifically cut Huawei off from reaching. Quick pause. If this is blowing your mind as much as it blew mine researching it, smash that like button right now and drop a comment telling me, do you think Huawei actually pulls off real self-reliance here? Or is this whole story more fragile than it looks from the outside? I'm reading every single comment on this one, and I genuinely want to know where you land before we get to what happens next, because it gets even more complicated from here. So here's the honest picture, and it's more nuanced than either the China cheated headline or the China is unstoppable headline. That stockpile of smuggled TSMC dies is exactly why Huawei was able to keep shipping meaningful volumes of Ascend chips throughout 2024 and into 2025, even while SMIC's own domestic production was struggling under that brutal 20 to 40% yield ceiling. The TSMC dies were, in effect, a safety net. A way to keep the Ascend product line alive and credible in the marketplace, while SMIC quietly worked to improve its own numbers behind the scenes. But as of early 2026, industry analysts tracking this supply chain say that TSMC's C-die bank is effectively running dry, which means the exact safety net Huawei has been quietly leaning on for years is disappearing in real time. Going forward, Huawei has no choice but to depend entirely on SMIC's imperfect, multi-pass 20 to 40% yield process, with no backup plan hiding behind the curtain anymore. Every Ascend chip Huawei ships from this point forward has to survive that gauntlet for real. And here's the part that makes this whole situation even more precarious. SMIC isn't even the only bottleneck standing between Huawei and its AI ambitions. There's a second Chinese company Huawei depends on just as heavily, and its numbers might be even more alarming than SMIC's. Here's the layer almost every piece of coverage on this topic completely skips past. Building the processing core of an AI chip, the part that actually thinks, is only half the job. The other half is memory, and specifically a category called high bandwidth memory, or HBM. HBM sits physically right next to the processor on the same package, and its entire job is feeding data into the chip fast enough to keep up with modern AI workloads. Without enough HBM, even a perfectly manufactured Ascend processor becomes a bottlenecked, underwhelming AI accelerator, like having a brilliant engine bolted to a fuel line that's far too narrow to actually feed it. The company responsible for building China's domestic HBM supply is called CXMT, Changxin Memory Technologies. And CXMT's numbers, when you actually run them, might be tighter than SMIC's entire yield crisis. Industry projections suggest CXMT will produce somewhere around 2 million HBM memory stacks in 2026. That sounds like an enormous number until you factor in exactly how many stacks each Ascend 910C class chip needs to function. At which point CXMT's entire annual output translates into support for only roughly 250,000 to 300,000 finished Ascend chip packages, total, for the whole year. Now put that number side by side with SMIC's raw manufacturing capacity. SMIC alone has die fabrication capacity for well over 1 million Ascend chips a year. Accounting for that punishing yield rate, that's still hundreds of thousands of usable chips SMIC is physically capable of producing, which means the processing side of Huawei's supply chain can output roughly 4 times more finished chip capacity than the memory side can actually support with usable HBM. You can build the brain. You just can't feed it fast enough, at scale, with what's currently coming out of Chinese memory fabs. That's the real power struggle hiding underneath the headline everyone's using. It isn't a boardroom feud, a public falling out, or some dramatic executive rivalry. It's a structural bottleneck where Huawei's ambitions, SMIC's manufacturing limits, and CXMT's memory shortage are all quietly pulling against each other at the same time. And whichever piece of that triangle breaks or bends first is what actually determines how fast, or how slowly, China's entire AI chip strategy moves forward this year. Long before you had ever heard the names SMIC or CXMT, those two companies were already quietly deciding how many real working AI chips China could actually put into the world, regardless of how ambitious Huawei's roadmap looked on a slide deck. So, does China have any real way out of this bottleneck? Or is this simply the ceiling Huawei has to live under? Because a new player is stepping directly into this fight that almost nobody outside the industry saw coming. In March 2026, Reuters reported that Huahong Group, China's second-largest chip maker, historically overshadowed by SMIC, began readying 7-nanometer production capacity at its Huali microelectronics facility in Shanghai. On the surface, that might sound like a small technical footnote buried in an industry trade report. In reality, it's a direct structural challenge to SMIC's effective monopoly over advanced Chinese chip manufacturing. For the first time, Huawei may not have to depend entirely on a single struggling foundry with a 20 to 40% yield rate. It could start splitting production across 2 homegrown manufacturers, which would meaningfully reduce the risk that one company's ongoing yield crisis single-handedly throttles China's entire domestic AI chip supply. SMIC, for its part, isn't standing still either, even while wrestling with its yield problems on Huawei's chip. The company has already moved into pilot production of a 5-nanometer class manufacturing process, and separate industry reports indicate Huawei has begun taping out its first 3-nanometer chip designs, meaning finalizing and locking in the actual circuit blueprints. Using a next-generation transistor architecture called Gate-All-Around, or GAA, which wraps the transistor's control gate fully around the channel instead of just sitting above it, allowing for tighter, more power-efficient designs than older transistor structures can achieve. The current target for mass production sits at late 2027. If that timeline actually holds, it would represent China closing a manufacturing technology gap that, under normal global industry conditions, typically takes years to cross. There's also a longer-term wildcard sitting behind everything discussed in this video: China's domestic effort to build its own extreme ultraviolet lithography machine. The exact category of equipment export controls have kept firmly out of Chinese hands, and the exact missing piece that's forcing SMIC into that grueling multi-pass DUV workaround in the first place. Current reporting describes China's domestic EUV effort as a laboratory success, not yet a factory-ready production machine. Whether China manages to get a working domestic EUV system into actual mass deployment is arguably the single biggest variable in this entire story, the one development that could make SMIC's yield problem disappear almost overnight, versus the alternative, where Huawei stays trapped fighting this internal bottleneck for years to come, one grueling multi-pass wafer at a time. So let's put the whole picture together, because both the China has already won the chip war narrative and the China's chip program is quietly failing narrative are missing what's actually happening underneath the surface. The triumphant version of this story, Huawei doesn't need the West anymore, isn't the full truth, and it never really was. A meaningful share of Huawei's celebrated self-reliance was quietly propped up for years by smuggled TSMC dies, funneled through a shell structure specifically designed to hide that dependency from public view. And even now, with that safety net running dry, SMIC's own yield rate for Huawei's flagship chip sits at less than half of what any mature, commercially healthy chip process should deliver. But the dismissive version of this story, China's chip program is quietly falling apart, misses something just as important. Despite an active yield crisis, a genuine memory bottleneck, and a billion-dollar sanctions evasion scandal now fully exposed, Huawei is still targeting roughly 1.6 million Ascend dies produced in 2026. SMIC is already piloting 5-nanometer production despite everything working against it. A second major domestic foundry is actively entering the fight specifically to break SMIC's monopoly. And Huawei's next-generation 3-nanometer chip is already sitting in the design pipeline, targeting mass production within roughly 2 years. That's not a program quietly collapsing under pressure. That's a program under genuine, serious internal strain. And moving forward anyway, one imperfect batch of silicon at a time. That's the real story hiding behind the polished Huawei brand name and its confident public messaging. The actual battle for China's chip future isn't happening on a stage in Shenzhen in front of cameras and press releases. It's happening quietly, invisibly, inside Chinese fabs in Shanghai and Beijing, between the company that designs the dream and the companies that have to actually build it. With a 20 to 40% yield rate, a shrinking memory supply, and an emptying die bank, all quietly deciding the outcome before Huawei's marketing team ever gets a say in the matter. Let's bring this together. Huawei doesn't manufacture its own most important chips. SMIC does. And SMIC's yield rate for Huawei's flagship Ascend 910C currently sits between just 20 and 40%, far below what a healthy chip process requires. Teardown investigations found a huge share of Huawei's supposedly homegrown chips were actually smuggled TSMC dies, funneled through a Cayman Islands shell company, in a scheme that cost TSMC a $1 billion fine. And that safety net is now running dry heading into the back half of 2026. Meanwhile, China's domestic memory supplier, CXMT, can only support a fraction of the chips SMIC is physically capable of producing, creating a structural bottleneck between processing capacity and memory supply that no amount of confident messaging can paper over. This is the real power struggle underneath the headlines. Not Huawei versus America, but Huawei versus the limits of its own country's supply chain. Let's run through the numbers one more time, because together they tell the real story. 20 to 40%. SMIC's current yield rate on Huawei's most important AI chip. 2.9 million. The number of smuggled TSMC dies investigators found hiding inside Huawei's supposedly homegrown chips. $1 billion, the fine TSMC paid for its role in that scheme. 2 million, the number of HBM memory stacks CXMT can realistically produce this year, against a foundry capacity built for well over 1 million finished chips. And late 2027, the earliest realistic date for Huawei's next-generation 3-nanometer chip to reach real mass production. Individually, these are just numbers about factories, yield rates, and shipping manifests. Together, they describe the exact fault line that will decide whether China's chip-independent story is genuinely real, or whether it's still being quietly held together by a shrinking pile of foreign silicon nobody was supposed to notice. If this video just showed you something about the chip war that literally no other channel is talking about, do me one favor before you go. Hit subscribe, because I'm about to keep digging into exactly what happens when that TSMC die bank finally runs out completely. And drop a comment right now with one word: SMIC. If you think China's domestic chip industry pulls through this bottleneck on its own, or stuck, if you think this internal power struggle is what finally slows Huawei down for real. I read every single one, and I genuinely want to see which word wins. Thanks for watching. We'll see you in the next one.